We are going to learn Laplace inverse. So write these formulas side by side. Okay, that's why I want you to write in a separate sheet like this. So all the Laplace inverse formulas will write side by side so that you'll get easily understanding. Okay. So what is inverse? Nothing. We'll take this L this side. This becomes L inverse. So L inverse of f bar of s is f of t. But the thing you should clearly understand is we always apply Laplace inverse on s and we apply Laplace on t. So don't get confused, okay? Whenever you see s term, we always apply inverse, okay? Then we get the output as t. But here input is only t and output is s. That is the difference you should understand. Okay. So now these are the formulas, and these, if you want for quick calculations, we convert 1 to 1 by s, t to 1 by s square, t square to 2 factorial by s cube, like that it continues. But see, a small trick here is, here the degree is increasing, 2, 3, so on. And when you see this side, this way, s ki 1, s square ki t, s cube ki t square, it is decreasing. If you don't want, you don't need to memorize this. Directly you remember this one formula. So every time you do in rough work, okay? If you don't want, don't take any stress. Just leave it. Okay, now focus on these formulas. Laplace inverse of 1 by s. This came from this only, okay? We kept here, n is 0. Then we get 1. Next, Laplace inverse of 1 by s minus a, e power at, s plus a, e power minus at. Here this is very important. Many people forget a. Here we have 1 by s square plus a square. A is constant, no? N is also constant. So you should remember that. N factorial, a, all these are constant. You should not forget them. Okay. So once quickly see these all formulas. Same formulas, but this also. You also write in sin h at also. You should not forget a here. Okay, you understood now? Everything is reverse. Next, let's go to properties directly. The first one is inverse linear property. So same here also. I told plus or minus, we can easily Laplace of this, Laplace of this, you can easily divide, no? Here also same. Laplace inverse of this and Laplace inverse of this. If it is plus or minus, not for into or division, only plus or minus, we can apply linear property. Now let's see some questions. Okay, for some time I'll keep this formula side only. You should remember all this. Okay, here s cube is there, but we need in formula we have s power n plus 1, so we need to write in that form, in that type. Okay, 1 by s2 plus 1. So now n is 2. Therefore, what is this will be t power n by n factorial. Which we should you choose, this form or this one? This is for n for natural numbers, this is for fractions. So we should use this one. So the answer will be t square by 2 factorial. Okay. Next, this one. This is a fraction, clearly, right? This also we should write in term of n plus 1. So I'll write 1 by s power 3 by 2 plus 1. How did I write 3 by 2 plus 1? If you are confused, just write like this. See, 5 by 2 is x plus 1. Then you'll get x, which is 5 by 2 minus 1, that is, okay. 5 by 2 is x plus 1. Write like that, then you'll get x is 5 by 2 minus 1, which is 3 by 2. Like that we'll get, okay. Whatever you don't know, put it x. Okay. Now, what is my n here? 3 by 2. So the answer will be this formula. T power 3 by 2 by gamma 3 by 2 plus 1. Okay, which is gamma 5 by 2. What is this? This one, s plus 3. So this will be e power minus 3t. Okay. Look at this, s square plus 3 square. That means it is pakka sine formula, right? Sin 80 formula. But what is there? 2 is there. So put constant outside. 2 into Laplace inverse of this. So what is like this, right? Laplace inverse of 1 by s square plus 3 square. So 2, what is this? sine 3t by 3. Okay, or 2 by 3. So did you understand? Sine 3t by 3. Okay, you should not forget the 3 answer. Okay, this is linear property. So this we can write as Laplace inverse of 1 by s cube plus same like Laplace linear property. This is also same. Minus Laplace inverse of s by s square plus 1 square. So this is this one, t square by 2 factorial. This will be e power minus 3t minus, what is this? S by, some means cos, plus is there, so cos. So cos t, a is 1, so cos t. Okay, so this is linear property and some basic formulas you should remember. Did you write all these formulas in separate sheet? Write side by side only. Okay. So see this question. Do we have any property for division? No. We have only for plus or minus. So we will write it like this. S square by s cube 1 by s minus 3 by s square plus 4 by s cube. Now I can apply linear property. No, that's why we divide it like this. So Laplace inverse of 1 by s minus Laplace inverse of 3 by s square plus Laplace inverse of 4 by s cube. Now which formula? 1 by s is 1. Here 3 by s square is, I mean 1 by s square ki t. So this will be 3t. If you want to see the formulas, okay, and do in rough work. Then 4 by s cube. So this will be t square. 1 by s cube ki t square. So 4t square. Okay, t square by 2 factorial kuda vastadu kada. Yeah, 2 factorial 2. So this will get cancelled. So we should not forget this 2. That's the main thing. So this will be 1 minus 3t plus 2t square. Okay. Now see, here in denominator only one term is there. That's why you usually did. Now what will you do for this? This also same. Like that. See, Laplace inverse of 3s by, don't make mistake in dividing it like this, okay? We cannot divide a denominator, we can only divide numerator. Sorry, I am telling divide separate. I mean to separate. Okay. Minus 8 into Laplace inverse of 1 by 4s square plus 25. Now, can you see anything? In my formulas, I have for s square plus a square. So I have to create it in that same form. And I don't want s square any coefficient. So I will take that common. Okay. So I will write Laplace inverse of 3 I can take common. Okay, we'll take later. 3, 4 I am taking common and I am making it s square plus, this is 5 square. 25 by 4. Here also minus 8. Laplace inverse of 1 by 4 common s square plus 25 by 4, or I can write 5 by 2 whole square, right? Here also same and did you understand? Okay, sorry for this clumsiness. Okay, we'll do here. So now Laplace inverse of, I'm taking 3 by 4 outside. 3 by 4 outside. S by s square, this is, what is this? 5 by 2 a square. So a is 5 by 2. Can you see? Same. A is 5 by 2. So which formula I should apply? Cos 80 formula. So this will be my, I'm directly writing. You understood, no? Cos 5 by 2. And here I'll take 4 outside. 8 by 4 minus 8 by 4. Laplace inverse of 1 by s square plus a square. What is a? 5 by 2. So this will be sine formula. But don't forget to write a also again. So this will be sine 5 by 2t. Sine 5 by 2t by 5 by 2. This also you should write. Okay. So cancellations 2, it becomes 4 by 5. So I think we'll get something like this. 3 by 4 cos 5 by 2t this going upside, minus 4 sine 5 by 2t. Okay. Okay, now let's see first shift property. Same way. If Laplace of f of t is f bar of s, then Laplace of I told an exponent term multiplied, we'll get s minus a. We'll shift s to s minus a. In the same way, here, if Laplace inverse of f bar of s is f of t, then this one, see, f bar of s minus a, if I apply Laplace inverse this side, I'll get e power at into f of t. That is what I wrote. So, you'll understand with questions very well. See this. Laplace inverse of 1 by s minus 2 whole cube. So, this, I will write it like this. Laplace inverse of 1 by s cube I'll write. But along with this, I have to write e power 2t. Only then I can shift. You understood? So this is like simply you are reducing the size. See, s minus 2 I reduced happily, but for that action you need to put reaction here, that is e power 2t. Okay, before what we did, before we see exponent here and then we shift. Now we are shifting it s minus 2 to s. Did you understand? So we are shifting s minus 2 to s. Okay, this is the answer. So the further answer will be e power 2t. Laplace inverse of 1 by s cube will be t square by 2 factorial. Over. Easy, no? Now see this question. I want to shift. S plus 2 is there. I can clearly see, no? So s plus 2 I want to shift to s. Okay, I will shift. I'll easily shift. S square plus 2 square. But what should I write outside? I should write e power minus 2t. Okay, you should write this. Then you can happily write this. Clear? Now, how will you solve this? E power minus 2t into what will be this? S by square plus 2 square means this is cos formula, no? So this will be my cos 2t over. Clear? Now let's see this question. Here also I can see something s plus 3, but I also want another term in denominator to simplify my question now. So this is quadratic, pakka it will have roots, or else we can find something like first check for 1 square. I am checking for 1, s plus 1 whole square. I'll get s square plus 1 plus 2s. So I have s square, I have 2s, I also have here 1. 4 will be left out, no? So let me write this as 1 plus 4. So now this term I can write it as s plus 1. So let's write. Here also I'll write like this. Okay. Now, so now how can I shift? I'll shift my s plus 1 to small term s, and I'll write this as s plus 2 by s square plus 2 square. But outside I should write pakka e power minus t, minus 1t. Okay. See here s plus 3 is there. If I want to shift s plus 3 to s, I don't have anything in numerator. What will I write for numerator? So that's why we should have in both terms. Only then we can shift easily. See, before also you can shift s plus 3 to s, but that makes no sense, because here upper term you'll get s. See, numerator you'll get s. Denominator will be same because you are unable to shift it. But we don't have any formula for this. No, what will you do by shifting s plus 3? That's why we want a term that so that we have a formula. See, now I have a formula for this. I have no. That's why we are doing it in this way. I'll show you how this will come. We'll complete this. See. So this will be my e power minus t Laplace inverse of s by s square plus 2 square plus 2 by s square plus 2 square. Can I do it like this? Yes. So this will be my Laplace inverse of, I am writing it like this, Laplace inverse of this plus Laplace inverse of the linear property. Next step I wrote like this. Now what will be this formula? Cos 2t, right? So let's write cos 2t. So this is my sin 2t. Sin 2t but I should write this as it is. I'm putting outside, and because I have to write by 2, no, so over. So your answer is e power minus t cos 2t plus sine 2t. So because we have formula for s square plus a square, we did it like this, and we are not shifting s plus t to s. If any of you have any doubt like why are we doing so, that's why I told. So here also same. You know that we don't have any formula for this type, quadratic type. So we have to write it to something like s square plus a square or s square minus a square. So we'll try. So here 4 I can see and I can see minus. So let me try for s minus 2 whole square. The answer is s square minus 4s plus 4. So I can create this here. So I will write this as, so in denominator I am doing s minus 2. So as I told you before, I need in numerator also s minus 2, no? So I will create s minus 2 plus 2. No worries in this. Let's see how denominator gets changed. So s minus 2 plus 2. Here you write s minus 2 whole square. See, in my minus 12, I have plus 4. How much more should I have to get minus 12? I should get minus 16. Only then minus 16 plus 4 is minus 12, isn't it? So that it will be balanced. So I'll write here minus 16. If you want, you expand it here. You'll get s square minus 4s plus 4. 4 minus 16 is minus 12. So same. Okay, if anyone have doubt, that's why I'm telling this detail. Okay. Next, I'm shifting my s minus 2 to s. So I'll write Laplace inverse of s plus 2 by s square minus 4 square. But I should write here e power what? 2t. This is must. Okay. Now e power 2t. What is this? We already did know before, s by s square minus 4 square. So I'm directly writing linear property. 2 by s square minus 4 square. So this will be which formula? Cos ht. Can you see? Minus is there, s is there. So it is cos ht. So my a is 4. So the answer is cos h4t. Here, here some constant is there. Guys, wait. Okay, sorry. So now I'll put this 2 outside. For clarity, I'm writing it like this. 1 by s square minus 4 square. So e power 2t cos h4t plus 2. This is my sin h4t. A is 4 by 4, right? So I'll cancel it like this. Okay, so the final answer is e power 2t cos h4t plus 1 by 2 sin h4t by 2. Okay. So this is nothing but derivative of this. So if we do ulta, if I put my L this side, then it will become Laplace inverse of this. And if I consider n is equal to 1, then I'll get s into f bar of s. So see, that is what I wrote. Laplace inverse of s into f bar of s is equal to what is left this side? F power n of t or derivative of f of t. That is what, same both. Okay, this is 1. See, everything it's ulta, but names keep changing. So this is done. Why did we call multiply by s? Because s is multiplied here. Next, let's see divide by s. See, in divide by s, so here also we took it from Laplace transform of integrals. See, f bar of s by s is there. So this is only our divide by s property. Where just transferring L to this side, it becomes Laplace inverse. Then the answer will be the left out thing. What is that? Integral 0 to f of t dt. So did you understand? So next is inverse Laplace transform of derivatives. So Laplace transform of derivatives, you know. Inverse Laplace transform of derivatives means you should have derivative inside. From where we'll get this? See here, you can see clearly we have derivative of f bar of s. That means pakka we are going to derive this from this property only. See, so if I send my Laplace this side, it happens to be Laplace inverse of derivative of f bar of s. Then my answer will be t into f of t, but minus we should take care. So minus t into f of t. F of t is nothing but Laplace inverse of f bar of t. So in this inverse topic, everywhere wherever you see f of t, this you should write it as Laplace inverse of f bar of s. That is only no. So we should write it like that. So what I'm trying to say is, from here, from this right hand side, we are getting new properties in inverse topic. Did you understand? Inverse Laplace transform of derivatives. From this, I have derivative here for s. So from this, see here, what I need, everything is completed. Inverse Laplace transform of integrals is not done. So that means I should have integration on LHS. Where did I have integration in RHSC? In divide by t property, I have like this. So if I send my L this side, this becomes Laplace inverse of some integral. That is only my property, inverse Laplace transform of integrals. Then the answer will be f of t by t. So this is what I'm trying to say. You should write it in this way, side by side. Okay. On cell display, you put pause and write this sheet. So now I think you're very clear how we got, and even if you forget, you can easily find these properties from your right hand side things. You can easily do it. Okay, very happy I told you all this. Minus log s minus 1, we can apply linear property, but what I'm trying to say is we don't have any formula for Laplace inverse of log of something. But do you know this? Let's say this is f bar of s. Then do you know derivative of f bar of s? For that, do you know Laplace inverse? Let's see. What is derivative of f bar of s? Log s plus 1, 1 by s plus 1. For this, 1 by s minus 1. So plus inverse Laplace transform of derivatives, we know that Laplace inverse of derivative of f bar of s is minus t f of t. We know. So that's why I did it like this. I don't have formula for this. I don't know how to solve Laplace inverse of log. That's why I took derivative. Now I'm applying Laplace inverse because I have property. I'll write this is equal to minus t f of t. Okay, let me write it. So this is equal to minus t f of t. So I'll consider this two steps. See, Laplace inverse. What is this answer? E power minus t minus e power t. Isn't it? So this is equal. This will be my. I'm bringing minus t this side. F of t is Laplace inverse of f bar of s. This is what I have to find, no? This is what I have to find. So the answer is e power minus. So this is the inverse Laplace transform of derivative formula. You should remember. So Laplace inverse of derivative of f bar of s is minus t into f of t. Or we can write minus t into f of t means nothing but Laplace inverse of f bar of s. I told you now, in whole this topic, wherever you see f of t, you should write Laplace inverse of f bar of s. Now what is given? This is my Laplace inverse of f bar of s, isn't it? So I have to find this. That means I have to find this term. That means I have to send my t this side. Okay, it will go to denominator. You understood? So now what will I do? I have to, this is my f bar of s. So you write here f bar of s is tan inverse of 1 by s. Okay, derivative of f bar of s. What will it be? Tan inverse of 1 by s means 1 by 1 plus into 1 by s inner derivative is minus 1 by s square. So this get cancelled. So we'll be left with minus 1 by 1 plus s square. So now this is my this one derivative of f bar of s. If I apply Laplace inverse, we have to apply Laplace inverse, no? So let's write here Laplace inverse of derivative of f bar of s, which is Laplace inverse of 1 by 1 plus s square. This will be equal to minus t f of t. So now what is 1 by 1 plus s square? Sine t, no? So let's write minus minus get cancelled. So I'll get this side sine t. I'm bringing this side t, which is equal to my f of t. What is my f of t? Laplace inverse of f bar of s. So this is the question, Laplace inverse of f bar of s. So this is also same question. Find Laplace inverse of this. So what is the first point you should write? Inverse Laplace transform derivatives gives that Laplace inverse of derivative of f bar of s is minus t f of t or minus t Laplace inverse of f bar of s. Okay. So now I will write this as Laplace inverse of log a by b means log a minus log b. So log s into s plus 1 minus log s square plus 1. So which is again log ab. So log a plus log b. So directly if you want you can write this step. Okay. So now this is my Laplace inverse of f bar of s, which I need to find. This is the term. So I have to find this term. So let me consider, what should I consider? Derivative of f bar of s. So which is this derivative of this whole term? Log s plus 1 minus log s square plus 1. Okay. So now what is derivative of log s? 1 by s. Derivative of log of s is 1 by s plus 1. For this it is minus 1 by s square plus 1. And inner derivative also will be there, no? So this will be 2s. For s square inner derivative is 2s. Okay. So this is, next we should write Laplace inverse of derivative of this. That is what I have to write. Is equal to minus t, directly I'm writing minus t Laplace inverse of f bar of this. So what is this? Laplace inverse of 1 by s plus 1 by s plus 1 minus 2s by s square plus 1. So this will be Laplace inverse of 1 by s is 1. Laplace by linearity property. Laplace inverse of 1 by s plus 1 is e power minus t. And for this, I'm putting 2 outside. S by s1 s square plus 1 square. That means it is cos t. So I'm bringing this minus t this side. So this is the answer. Over. This is what we have to find, no? Laplace inverse of this. So this is your answer. 1 plus e power minus t minus 2 cos to the minus t. So how to find Laplace inverse of f bar of s? Okay, what is the formula I have? Laplace inverse of derivative of f bar of s is minus t f of t, which is this Laplace inverse of f bar. So from this formula I can find out. So now I have to find derivative of this. Do you know derivative of this? Yes. So let's find out. This will be u by v. So we'll get, wait, let me write it. Derivative of s by s square plus 4 whole square. Then we'll get power 4 down, and again we have to take Laplace inverse, so it will get lengthy. So here we have another method to do this question. So this question is very important. See, let us take, here we took f bar of s as this whole term, no? Let's not take like that, okay? See, don't do it in this way. Here let f bar of s be 1 by s square plus 4. Then what will you be your derivative? You will get minus 2s by s square plus 4 whole square. So it is getting created. If you can see, if you take out minus 2, see your question is created. So in these times, so when this question is created, if you take only one piece, then you have to do this sums like this way. So now what we will do, we'll apply Laplace inverse on both sides. Apply Laplace inverse on both sides. So that will be minus 2 Laplace inverse of s by s square plus 4 whole square. So this is your question now. This part is your question, isn't it? Then the answer will be by minus 2. So that's it. This is easy, no? Derivative of this is easy, which is minus t f of t. Or I can write minus t Laplace inverse of f bar of s, which is minus t. What is Laplace inverse of f bar of s? Means this one, 1 by s square plus 2 square, which is 1 by sine 2t by 2. Okay. So this you write this. So finally I'll get my Laplace inverse of s by s square plus 4 whole square as minus t sine 2t by 2 again into minus 2. So this will be, so the final answer will be t sine 2t by 4. This will be a final answer. Okay. So did you understand? When it is getting created, do it in this way. So this one, Laplace inverse of s to infinity integral. So what is the property you can think? It is which property? Divide by t property. What is divide by t property? Laplace of f of t by t is equal to s to infinity f bar of s ds. So from this, Laplace inverse of this is equal to f of t by t. So this we call it as inverse Laplace transform of integrals. So Laplace inverse of f bar of s means this term, 1 by s minus 1 by s plus 1, which is 1 by s 1. For this it is minus e power minus t, right? So this is my f of t. Laplace inverse of f bar of s means f of t. So what is the answer? Or Laplace inverse of s to infinity f bar of s ds is equal to f of t by t. So now the answer will be this by t, right? So therefore Laplace inverse of s to infinity 1 by s minus 1 by s plus 1 is equal to f of t by t, which is 1 minus e power minus t by